हरे कृष्णा स्टूडेंट्स। तो इस वीडियो में हम लोग पावर के बारे में चर्चा करेंगे कि व्हाट इज बेसिकली पावर। सो एज वी ऑलरेडी नो अबाउट पावर, that power is the energy or the work done per unit time. So energy generated or energy used per unit time becomes power. So if we see here, then we know that, let us say this is the circuit. So in this circuit, what is the situation is shown that this is the resistance R1 and here it is a battery. So this battery has an EMF of E and internal resistance small r. Now what is happening? This complete is one battery. Fine. So we know that like, it will generate some current in this circuit. So this current can be written as I, and I can be written as E upon small r. Oh, this one. So this I can be written as like this. Fine. So if this I can be written as like this, so basically let us see here how this power is calculated. Fine. So for this, what we will do, let us assume one point. What is that point? Let us say this point is A. Fine. This point is B. So similarly this point and this point is somewhere here C. Now you see here, let us say I say that the potential of point A becomes 0. Fine. If the potential of point A is 0, then the potential of point B will automatically, what will happen? We'll go from this side to this side. When we'll cross the battery, then the potential should increase. And on this side, the potential will become E. Fine. And as we know, when we will pass through this battery, or sorry, this resistance, so on this side, potential of C will come. And the potential of this point was E. So when we will go here, potential of point B was E. When we went to this side, then there was a potential decrease and this became E minus I R1. Fine. So basically these are the potentials of all these points. Fine. Now let us say that I am telling that a dq amount of charge, dq amount of charge, dq charge goes from point B to point C. How much charge? dq charge in dt time. Fine. So what basically I'm telling, that a dq amount of charge goes from point B to point C in dt time. So if we see that this point, this charge dq earlier was at a potential VB, fine, and now it is at a potential VC. We know that there is a concept that we call as potential energy. So what is potential energy? Potential energy of a charge is always written as charge into voltage at that point wherever it is kept. So we can say that if we see in this resistance R1, there was a point VB and here is the potential VC. So the potential VB gave a potential energy dq into VB to charge B. Correct? So the potential energy of the charge dq became dq into VB when it was here. And the potential energy of the same charge became UC when it was at that point where potential is VC. Correct? So this charge has traveled from here to here. How much time it took? It took dt time, and there was a potential change, potential energy change. Now we can see that the difference in the potential energy UB minus UC can be very easily written as dq into VB minus VC. So if we will see here, then we can see that, sir, yes, there is a decrease in potential energy. Why there is a decrease in potential energy? Because see, this is VB and this is VC, and here we can see the potential of VB was E and the potential of VC was E minus IR. It means there was a drop. And if we see, if we calculate these value VB minus VC from here, then we will get this value as IR1. Correct? Fine. This is fine. and this is the potential energy loss in potential energy. Now, where this potential energy has gone? This has gone to heat generated. So whenever current pass through a resistor, there is a loss in the potential energy of charges, and where that loss goes, this loss goes in the heat generated. That's why our bulb, na, they becomes hot or they gives light. How? Because there is a loss of the charge potential energy. And how much is that heat generated? Heat generated became dq into IR1. Now the next point what we said is that, sir, this heat generated has taken place in dt seconds. So if we want to calculate power dissipation, so what we can say, power dissipation becomes heat generated divided by time taken, and this became dq by dt, and dq by dt we know what we can write is current. So the formula became I square r. This is the very known famous formula that the power dissipated in a resistor can be written as I square r. If we keep I and IR like this, then this becomes the potential difference. So this became IV, and this more further can be written as V square by R. Fine. So this is the very famous formula, that is the power dissipation across a resistor. Now, how much is the power generated by battery? Because if the resistor has dissipated the power, then someone must have generated this power. So who does that part? Who this part is our battery. You know that like our battery gets discharged when it is used. So that power has gone from battery. So let us see that okay, how to calculate power of battery. The power of battery is also very simple. If we see, then actually there is some issues. I will tell you very important thing. In reality, battery, what power battery has produced and how much is actually usable. So power usable and power produced by battery. These are actually two different things. See, I will tell you. See here, this battery has a EMF E, and this point has a potential A, this point has a potential B. So if I apply the same concept, dq charge was here and then this dq charge went here. So what we can say? We can say, sir, this dq charge earlier when it was here, I have assumed the potential of point A as 0. So it means that dq charge has potential energy how much? 0. But when it has gone to point B, its potential became E. So its potential energy became E dq. And in this situation, we know that when the charge has gone from here to here, then its potential energy has got increased. So who has increased that potential energy? That is done by this battery. So whenever a charge passes through a battery, a positive charge goes from its lower terminal to its higher terminal, then the potential energy of the charge has got increased. And this potential energy of charge has got increased. It means someone has given that potential energy to that charge, and that who is he? That is our battery. So if we see here, then we can write how much UB minus UA. And if we see UB minus UA, this becomes DQ into VB minus VA. And if we write, this becomes DQ into E. And for power, what we can say in dt seconds, let us divide this whole equation by dt, and this becomes into E. This became what? This became I. So this is EI, and this EI is actually power produced by a battery. Listen here, this is very careful, very important. Power produced by battery is reality is this. But there is a resistance also within the battery. So this resistance is part of not of the main circuit. This resistance is the part of battery. So whenever we will switch on this battery, then our part is this small r, this capital R. But this resistance small r is already inbuilt inside the battery and it will automatically take its toll. We don't have to do anything. Every time it will take its toll. It means that basically what will happen, this power produced by the battery, some part of this will get lost. In what it will get lost? In its own internal resistance. Getting what I'm telling? So in this own internal resistance, how much is that internal resistance? Small r, and we know that the power dissipation across a resistance is I square r. So what will the loss? The loss will be I square into small r. So basically the power usable that will remain with us will become EI minus I square r. So we write it E minus IR into I. So this is a very important thing. Actually, see, battery they works with the help of chemical equations, and this is the chemical energy that has got utilized in 1 second. So chemical energy that got utilized. But the thing that we could use was this. You're understanding? So it means the efficiency of battery is also not 100%. So there are something known as ideal batteries. Ideal batteries, what they have? Ideal batteries, they have small r equals to 0. So therefore there is no energy loss in them. Fine. So was very wonderful discussion and this is very important for you. And after this, in the next video, we will do the problems that how we will decide. Like here we can see this is the problem that we're going to do in the next video, that how which bulb will get fuse, power rated, what is all these things are. Okay, thank you. Hare Krishna.